So it's a pretty straightforward process to measure the frequency response using a calibrated mic and a loudspeaker. And this software, there's a few different ones. This is called Room EQ Wizard. I'm going to just show you something else, just to have a look at the output, the frequency response, but actually from the rear of the speaker. So I've actually got the microphone at the back of the speaker. Now, we know that if the wavelength is big compared to the source size, then it will be omnidirectional. So it'll, like a balloon expanding out. So the bass frequencies are going to come round and we'll actually reach the microphone at the back, and that's the problem. When the boundaries at the back, those are going to reflect back. And the high frequencies, because they're quite small compared to the size of the source, will be very focused. Now that in itself could create problems, because if you're moving off axis, you're going to get a different tonal response. It also means the reverberant field in your room is changed by the directivity of the speaker. And the biggest problem that we're going to see from the following experiment is this bass frequency is going to be reflected back if you place it near a boundary. So let's just have a quick look at that. So go back to fuzz measure. I'll just press measure now. Okay, I'll just get rid of some of that craziness. So you can see the treble response is, as you'd expect, way off. We're hearing mostly reflections now. But if you look at the back, the bottom frequencies here, they're pretty much the same. And don't forget, we're measuring from the back of the speaker, so you can see there's all this output. It's pretty much the same as the front until it reaches kind of around about 400 hertz, something like that, 300 or 400 hertz. It starts to become attenuated or reduced because we're from the back of the speaker, but all these issues are low frequency. So let's try putting it next to a boundary now and see what happens to all this energy when it reflects.